Good morning, everyone, and welcome to Manitoba Agriculture and Resource Development Crop Talk webinar. If you have any questions during the presentation today, please type them into the questions section of the GoToWebinar menu, and we will answer them at the end of the presentations. This webinar is being recorded, and you will receive a link to the recording. Thank you.
Thanks, Lori. I'd like to welcome everybody to the June 2nd edition of Crop Talk. And this week, as we kind of mentioned last week, we're probably going to be getting ready for doing some in-crop spraying. I thought it'd be a good opportunity to get Kim on today to talk a little bit about issues that we deal with when we're spraying. And a lot of times it's anything from water quality to temperature and those type of factors. So I thought it'd be good to go over a brief understanding of that, and then also talk a little bit about inversions. We always seem to be dealing with that when it comes into spraying time. So definitely something to talk about there. Crop scouting panel is going to be on again, and we've got some questions regarding emergence and maybe some questions regarding frost. And so there'll be a few things coming up there, and then go from there. So first of all, just a few opening slides to kind of see where we've been and where we're at right now. Seeding wise, 96%, I would say we're, pretty much in most areas seeding complete, besides a lot of, I shouldn't say a lot, but some reseeding that's being done. I've heard of reseeding being done because of the frost. I've actually heard of a couple fields being reseeded because of flea beetles. So it's something to definitely, we're going to need to keep watching for the flea beetles. That's could be an issue still. And hopefully we don't have to deal with too many more frost issues. So we're definitely seeing a crop that did get affected, in most cases coming back. Where are we on our yield response to seeding date? And you can see right now that most of the crops were kind of right in that 75 to 80% yield stage so far are still. And I think again a little bit weather dependent. I think we're still probably a good 80% chance of getting those type of yields still, or 80% of your potential yield, which is still not bad as we go through the rest or completion of seeding. A big story this past week was the frosts, and we had a lot of areas reporting frost over the past week, and you can see by the map here, this was for the evening of May the 26th to the morning of May the 27th, and you can see that pretty much most of the province experienced some type of frost. Durations I think are probably the biggest issue that happened in some areas, and that's why we're seeing more issues or more damage done in some areas, because some of the frost started fairly early in the evening. Guys were telling me anywhere from 1 to 2 o'clock in the morning there was -1, and then we did get frost right through till 6 or 7 o'clock in the morning. So definitely a long duration, and definitely some cool areas. So this was for the 26th, and then when you look at the 27th, again, you look large portion of the province was anywhere from that 0 to -3 kind of temperatures. So again, experiencing frost. I think the duration was a lot shorter on the 28th, and then 2 nights ago, I guess we received another frost in some areas. So the frosts, there was probably 3 of them in general here that may have done some damage, and so a lot of producers were out checking fields, and there's a lot of producers doing stand counts now, trying to determine if there's still enough numbers, and in most cases there are. And I'll show a few slides here, or this slide here anyways, and this is just showing some of the regrowth that has happened since we got a little bit of heat over the past couple of days, and it's starting to bring on some of those crops that have frozen. So definitely seeing the crop recover. And I guess the next big thing is going to be the heat we're going to receive over the next couple of days here, because we're talking record highs in the next couple of days. So as long as there's moisture there, we're going to see the crop jumping fairly quickly. So with that, I think that's enough of a brief introduction, and let's turn the screen over to Kim, and we'll look at getting ready for spring.
Okay, thanks Lionel, and thanks Lori for getting me going on this. I'm just gonna get my slideshow going here. You guys can see my screen okay?
You bet.
You want me to switch screens?
Yeah, just so we can see the slideshow.
Yeah, hang on. Swap.
Just to display settings? Yeah, there you go. Perfect.
Yeah, sorry, it does that sometimes. Okay, get my pointer. There we go. I'm just gonna do that. Okay, so I've got a few topics here. I'll just got a few slides on each topic and we'll kind of jump around a bit, but Lionel had asked me to cover some of the things we're going to be dealing with. We've got sprayers rolling here in the Carmen area. Now, you know, crops are getting into the right stage. I'm surprised. Not that I want to see more weeds, but you know, there's still, you know, with the dry conditions and stuff, the weeds are coming. They're definitely getting there. We're really starting to see some of those warm season weeds now. And, but you know, not a heck of a lot of weed growth in some fields yet. So, so again, I think we may be holding off just a little bit longer to get some of those weeds up before we get spraying, but we're definitely getting very close to where we should be spraying based on crop staging. So spring herbicide applications, there's some work from Harker and O'Donovan. The yield effect of one weed emerging a week before the crop is equivalent to that of 100 weeds emerging 3 weeks after. So that's more for our pre-seed spraying and that type of thing. We are finishing off seeding, but we do have some guys just at the tail end of those burn-off sprays where they're, you know, getting that spray on before crop emergence. So if you still have the chance to do that, I would encourage you to do that. It's a way of extending the weed control throughout the season. However, we need to be really careful on that. Our later seeded crops come out of the ground really, really fast. And the minute you've got ground crack on anything, you need to pull the plug on that because you're going to do some damage. You think you're not doing damage, but you are. So you need to pull that away. And this is a funny talk too, because I didn't think we'd be talking about the after effects of a frost and also the effects of extreme heat within 1 week. But we did have a frost last week, a couple of frosts. There's definitely been some crop damage. If you've got tissue damage to more than 40% of the leaf, you want that to be regrowing before you start applying new herbicides. We've definitely been there we've got the temperatures now for spraying because we need to be basically above 8 degrees for at least a couple of hours during the day after some of these cold events. But we definitely need to have that new growth happening. I think if our growth is slowed down, it's more from drought now or lack of moisture more than temperature. Warm and sunny days are better than cool and cloudy for spraying, but sometimes we just take what we get for spray days. So I was gonna talk just a little bit about spray drift, and there's something here called the Beaufort scale, and also Tom Wolfe on Sprayers 101. That's an excellent resource for anything about spraying. Tom and Jason are just excellent resources. They talk about this upper limit of force 3 or force 4 winds, which is 20 to 25 kilometers an hour, which is 13 to 18 miles an hour, or what they call gentle to moderate breezes. So this in here is where we basically need to, this is ideal for spraying. Below this, we can run into potentially some inversion issues, and above this, the drift potential is just too big. So we need to be in here. On our guide, page 11, I think, of our guide to crop protection, we talk about, you know, to reduce spray drift, to spray in winds no higher than 10 miles an hour. So anyways, that's kind of right in this range, basically from 8 to 18 miles an hour. And again, depending on nozzles and a lot of other things, but wind is obviously a huge factor. So if you have to spray in the wind, We've had some days lately that there was absolutely no spraying because there's just nothing you could have done. But you know, when the winds are starting to get up there, but it's still okay to spray. If you can, choose a product that can handle large droplets, which is generally glyphosate, your group 2s, your group 4s, some of your contact herbicides, your group 16 and your PPOs here, or your 14s and then your group 15s, not as great for large droplets, but you know, we still do what we can. Soil applied herbicides obviously can tolerate big drops. It doesn't really matter there. So if you're using, use a low drift nozzle if you can, which is a coarse to a very coarse spray, and then of course based because of the way that nozzle is made, those coarse sprays break down, and then we do get good coverage out of those large droplets. Booms, keep your booms low. Now I've said 20 inches here, but honestly that really depends. You've got to look at the nozzle you're using, how much overlap you've got. If you've got low drift nozzles, you want 100% overlap. So you need to have that boom height set where as low as possible to still get that overlap. Slow your travel speeds down of your sprayer. Know what's downwind. Let the weather help you. So take the wind from the side if possible. Spray in the sunshine. The drift cloud disperses more quickly. So there's just a few tips there. If the winds are getting up into that upper end of where we can spray, just a few tips. Spray drift, there's volatilization, and there's also particle drift. So volatilization, that's vapor drift, and that's a lot, that's formulation. You know, first thing that comes to mind is our dicamba, possibly, you know, our esters as well, our 2,4-D and our MCPA esters. They're more susceptible to vapor drift than, say, an amine formulation of our 2,4-D and our MCPA. And a lot of that is temperature dependent as well. And you will see this in the guide. In every product page will have a heading, effects of growing conditions, and it's based on what's in that product's label. So it's different for every product, but I encourage you to look at that and look at the restrictions in that section. And then particle drift, though, is just movement of spray droplets. So that's independent of what type of herbicide you're spraying and that type of thing. The potential impact of herbicide drift, obviously risk of injury or damage to human health, risk of injury or damage to susceptible plants, which could be adjacent crops, or non-target organisms, which could be wild and domestic animals or pollinating insects. Again, this is, you know, not from a herbicide perspective, but we're spraying a lot of insecticides this year, or this time of year right now too, because the flea beetles are out there in full force. And sometimes, you know, we're out spraying and unfortunately reseeding when it gets bad enough, as Lionel had said earlier on in the talk. And also just the environment and property in general, you have to, you know, need to be aware of where that spray could be going if it's drifting. Reduced efficacy on your crop. So if the spray is drifting off your crop, it's not on your crop. And so we're getting less, you know, less weed control because the spray is physically not hitting the targets it's supposed to. And it's wasted money and time, which we don't have an abundance of either of those most days. Factors affecting spray drift was inversions, relative humidity, wind speed and direction, droplet size, but that's a function too of nozzles and pressure, boom height and travel speed. So I'm just going to touch on just a couple of these. I wanted to showcase the Spraycast, which is the Manitoba Potato Weather Network. This is just a screenshot of their main page. And then, oops, sorry, I hit the wrong button. This screen here, basically anywhere in this red zone, and this is a very easy site to use. I've just screenshotted this, but I would encourage you to go on this site and you can zoom, click your location within the boundaries, and you'll actually retrieve the 3-day spray advisory weather forecast. You can actually, if you want a specific location, you can do that. There's a bar there. Again, this is just a screenshot from their main page. And then you're going to get something that looks like this. And so you're going to get, like basically this was from last year. So this is June 10th, and here's June 11th. And it basically talks from 12 a.m. all the way up to 12 a.m. And it's got everything. Here's wind direction, speed, precipitation, temperature. So this is a really great resource. In red here, it says don't spray. Here we've got, you know, poor spray conditions for fine droplets, fair for medium, and good for coarse. But still in this time frame, based on the forecasted weather, then we're looking at a no spray time period in this window here. And unfortunately, the next day, Thursday, it's basically most of the day we're really not in good conditions for spraying. So again, this changes by location and daily, and I would encourage you to go to this site if you're in that red zone where you can access this. So We also have on our own website local weather as it happens or as it's happening. These are just some screenshots off my phone. And so I go to our AgriMaps current weather conditions, and you're going to get a screen that looks like this. And all of these dots are weather stations. I've zoomed in on here. This is when I'm up in Dauphin and I'm looking at the weather stations close to me. And then if you swipe through at the bottom of the page, you actually can get your current, this one is wind speed and direction, but there's precipitation, there's temperature, there's all that type of thing at all of these stations. And so when you're spraying, this is also just a good idea too. You can take a screenshot of this. It'll have the date and time on that picture. And then you do have an idea of what the spraying conditions were like when you were spraying. So I really like this app. It's really not, sorry, it's not an app. I actually have this saved to my home screen on my phone, but I really like this. It's really quick and nice to use and gets me some current weather conditions, basically real-time weather. This is on that same site, but just a little bit a different place. This is again our weather conditions, and this is a couple of screenshots off my phone. This is our basically as of 10 o'clock last night. This is our Treeherne, the station at Treeherne, which is just kind of outside town there on the south side of the highway, about a half a mile east of town. And this tells me at that time, the temperature, the precipitation, our soil temperature, all of our factors. I really like this graph in here. This tells me our air temperature and relative humidity from 12 a.m. on. Basically, we've got a full day in here. And so those nights that we were talking about frost, this is the first place I go in the morning, because this is where I can see how low our temperature dipped and also how long the duration of that frost was. And there's other things here. Then if I'm talking spraying, I'm looking at this next one down. It actually would be below here on my phone, but I've had to take a couple screenshots to show you everything. And then this is wind speed and direction, and it kind of tells you kind of the trends, I guess. And then there's other information here as well. So that's another resource that we've got on our website. Now, how inversions affect dispersion. Basically, whatever is in the air, you know, the rising portion of a convection cell carries whatever particles are in the air with it. So basically, if we've got cooler air here in blue that sinks and warm air rises, so if we've got this happening, we have turbulence and we basically have some mixing, and basically this disperses the particles like dust or pollution. But a thermal inversion is where the cooler particle-laden air, it can't rise, even though normally warm air rises, but the cool air gets trapped in here, and the warm air, which is above it, is above, and you don't get that turbulence. And so basically then during this temperature inversion, where we've got cool temperatures closer to the ground than higher above, then these particles are here, and then they can start moving if there's any type of a wind at all. So I'm going to show you just some of the other factors. But inversions will form more rapidly when there's less vapor in the air to absorb radiation. So once humid air has cooled to the dew point, the water condensation gives us energy and warms that air a little, and that will slow the inversion. But be aware that inversion conditions can exist long before a fog or a dew or a frost forms, so they're not a good indicator of the beginning of an inversion. Usually by the time you see a dew, hopefully not a frost anymore this time of year, but when you see those dews, usually you're already in an inversion. So then you're already where you shouldn't be spraying. So inversion forecasting is getting better. It's location specific though, very location specific. So I encourage you to use all the tools you've got at your disposal to look at, to get as much information as you can. And there's lots of other weather sites available out there, private weather sites and things. And so again, I would encourage you to use more than one site if you can. But spray in general though, sprayer operators should learn to watch for the following cues. Basically large temperature swings between the daytime and the previous night. And again, if you're watching some of those weather sites, like I just showed you, where you can see that 12-hour time span or that 24-hour time span, that's a good thing to be watching. If it's calm, which is less than 3 kilometers an hour wind, and clear conditions when the sun is low. Intense high pressure systems, which are usually associated with clear skies and low humidity where you intend to spray. Dew or frost indicating cooler air near the ground. And again, by the time you see that, it may be too late. You're probably already in an inversion because it's cold enough near the ground to cause that dew or that frost. Smoke or dust hanging in the air or moving laterally, and I think all of us that live out in the country, you see this on the gravel roads when the cars are going down the road and that dust is just hanging there, and you can just see it like a shelf of dust as the cars are going up and down the roads. If odors traveling large distances and seeming more intense, daytime cumulus clouds collapse towards the evening, and also the overnight cloud cover is 25% or less. So a good rule of thumb is that if you suspect a temperature inversion, don't spray. And again, here, usually your red zone is your no-go between 10 p.m. and 4 a.m. Usually this is not this is usually where we get these inversions. By some years around, usually if our sunrise is around 5 a.m., we've got our inversions in this period and they're fading. This is usually in the green zone here, our best time to be spraying. And then depending on the day, again, these change, but you start to get your inversion building as our daytime temperatures start cooling off and we start heading for nightfall. So changing gears then, Lionel asked me to talk about water quality effect on herbicides, and we went over this a few weeks ago, but I'm just going to touch on it again. A few things that we need to look at. Cleanliness is a big thing, especially for certain chemistries. Our glyphosate would be our big one. But mineral ions, and we talk about hardness of the water, and then bicarbonates, and then in some cases iron and manganese. Those actually can oxidize and form precipitates that plug screens and nozzles, and that's not something that can corrected. So that's something that if it is specifically an iron and manganese problem, that's not something we can fix with adding anything to the spray tank. Best thing to do is to test your water. You're going to get a water test back depending where you send it, but you should be getting total dissolved solids. They'll actually add up the calcium, the magnesium, the sodium, the sulfate, the chloride, and the bicarbonate. Bicarbonate is HCO3. You'll see that sometimes. So make sure you get this bicarbonate number. pH, usually between 6 to 8 is fine. There's a few exceptions there, but they're exceptions to the rule, and normally pH is between 6 to 8, which is most of what we've got for our water sources. The salinity or the EC of groundwater can substitute as a measure for TDS. Basically, if your EC is more than 500, then probably no effect on pesticides. When we talk about water hardness, hardness is hard water has high levels of calcium and magnesium, and usually it's reported as calcium carbonate or CaCO3 equivalent. So other ions like iron, potassium, and nitrate, they're usually not significant. They do add a little bit in there, but your big things that affect your water hardness are basically your calcium and magnesium. Calcium and magnesium are positive charged, so this does affect your weak acid herbicides like glyphosate and the amine formulations of 2,4-D. So hardness above 250 to 350 parts per million calcium carbonate should be treated. Bicarbonates, which was HCO3, it's something a little bit different. That's usually associated with sodium in the water. It also can affect your dim herbicides. So that's your clethodim, which is your Select or your Centurion, and that type of thing. Your Post, those herbicides, and 2,4-D amine, and above 500 parts per million may need treating for that. And so this is just a website. This is from Washington State. So there's actually a calculator on here that I wanted to show you. And this is this says ammonium sulfate as a water conditioner to improve glyphosate efficacy. And basically on this website, it's based on some work that was done at North Dakota State University, this Nalawea and Matisiak in 1993. So this is older work, but they did a lot of work with AMS, and they came up with a really good formula, which is what a lot of the companies that sell water conditioners and water treatment things, and ammonium sulfate as well, to help you with your spray water, they use these formulas here. So this handy calculator, and on this website, if you just hit this link, you will actually get this right here. So if you've got that water test, you actually can type this in yourself and the date, but this is where you put the lab results in for these ions that are going to be on your water test. It's going to list them, and then basically it's going to tell you what you need to put on for ammonium sulfate. So this is basically the same test that some companies are using when they're testing your water for you and recommending using AMS type thing. So this is just a good, if you do have a water test, you can throw the numbers in and do it yourself, or there is some other calculators online, but I think this was the easiest one to use. So Switching gears again, spraying in hot, dry weather. We've gone from a frost last week to extreme weather conditions now. Herbicides are generally most effective when plants are growing vigorously, and usually that's in our temps of 21 to 28 degrees, maybe 21 to 30, somewhere's in there, but really that's our prime growing conditions. I encourage you to look at your effects of growing conditions guide in the section in the Guide to Crop Protection, our GCP. For example, if you flip to the dicamba page, it tells you to apply when there's other things about effects of growing conditions, but specifically for high temperatures, it says to apply dicamba when temps are between 10 and 25 degrees. I flipped the page over a few pages and then I looked at distinct and it says do not apply over 27 degrees. So, and I think when you basically whatever you're spraying, check the specific pages because there are very specific recommendations based on different products. And I'd encourage you as well. I know BASF has had some great stuff out lately too about spraying their pesticides in this hot weather, and basically most of them say to shut her down at that 27 degrees, 28 degrees sometimes, but a lot of times we're shutting her down at 27 degrees, so which it's going to be, we're going to be exceeding that for a few days here in a row. And the problem at spraying at those high temperatures, you get increased crop injury and or decreased weed control. And why? Because the weeds may be more tolerant to herbicides, and basically when they in these hot, dry conditions, they get a thicker wax barrier, thicker wax layer on the leaves, and that's a barrier to absorption. Metabolism is slower in that weed, and so herbicide movement within that plant to the target site where it normally would be working is slower. So the herbicides are just slower to work once they do get into the plant. Crop injury may increase because crop metabolism is slower, and normally our crops are metabolizing the chemistry that we're spraying on them, and so it doesn't hurt them. But when their metabolism is slower, we may end up with more crop injury, and we do see this more for contact herbicides. And again, when it's really hot too, our volatile herbicides are more susceptible to drift. And we talked about this a few slides ago. Our 2,4-D or MCPA esters and our dicamba are our worst culprits for that. So mitigation, what can we do if we have to spray? Well, first of all, if it's hotter than that 27, 28 degrees, you really shouldn't be spraying. But when we are in the upper end of the safe range to be spraying at, use lots of water. Doesn't matter whether it's systemic or contact herbicide, lots of water, you'll get good coverage. That's the first thing we need to be doing. For application rates, you need to be kind of at the high end of the labeled rates for your systemic herbicides, but maybe at the lower end of the labeled rates for your contact herbicides, because we do see they can cause a little bit more crop damage when the temperatures are getting to be extreme. And contact herbicides can sometimes tolerate a little bit higher daytime temperatures or temperatures when spraying, but you do need to look at the label on all of those because they are all a little bit different, and you need to follow what the manufacturer recommends. Using appropriate adjuvants and surfactants, those are really important. So they enhance the droplet retention on the leaf, they help dissolve the wax, and they hold the spray droplets on the leaf longer by lowering the evaporation rate. So those I would encourage you to use the appropriate adjuvants and surfactants, whatever's recommended. Depending on the product, you can use coarser droplets, and that's simply because smaller droplets dry faster. So I would be at the upper end of as coarse as you can get, again, based on which chemistry we're talking and what the manufacturer recommends, but spray on the coarser side if you can. When we are spraying in hot weather, we're spraying during the morning. Our plants are more hydrated. They're less droopy, basically. Our leaves are more open and erect, and you know how they get in the middle of the day. They get very hot and very dry, very droopy, and we see this in our crops and our weeds. And usually in our morning, there's more humidity, which just reduces the droplet drying rate, gives that chemistry more time to get into the leaf. And above all, though, wait till the temperatures are lower and or there's rainfall coming to reduce the environmental stress for both weeds and crop. And that was all I had for that, but I think there was a question or something, Lionel, that had come in earlier.
Okay, Kim, yes. There is a couple questions right now, so just give me a second here. The first one that came in while you were talking was, I missed my burn off and in my wheat field, and right now I have dandelions that are flowering. Do you have a recommendation as to what I might be able to use to get control of those?
Yeah, honestly, when you're spraying a crop like that is flowering, that's kind of revenge spraying. Now, if it's flowering, those seeds are viable. They're going to float around. They're going to be growing new plants. Really, right now, there's not a lot like going after a perennial plant in the spring is tough because it's a big plant. All the photosynthates and things that went down into the root to protect it over the winter and feed, over the so it can overwinter. They're channeling up now so that plant can grow. So once we hit flowering stages, like it is really tough to take out plants. Any of your in-crop sprays that will do, they'll crisp up the leaves and they'll maybe take down some of the surface area of that weed, and that'll help because it won't be competing as much for light and nutrients and that type of thing. But really, you need to be looking at if this is something that's happening more than just this year, then we're looking at a pre-harvest spray or a fall spray program to get those dandelions, because those dandelions that are flowering right now this spring, they were in your crop last year at harvest time. They were down on the ground, very low. Our pre-harvest spray sometimes has trouble getting right down to the bottom there, but a fall spray program works really well for something like a dandelion. And that's when you need to be going after that, because those will be growing and flowering very early in the spring, and they're really tough to get rid of them completely. But again, there are some good products that will definitely take some leaf area off them, but you're not killing it right now. There's just nothing really that you can be doing to get rid of it completely.
Okay. With the extreme heats where they're forecasting, when should I start spraying in evening or quit spraying in the morning? You kind of touched on that, I guess,
Yeah.
but I guess are we looking at a certain temperature to look at, or?
Yeah. Well, again, usually that 27, 28 degrees. And again, I would go to your guide to crop protection. Effects of growing conditions is pretty much, I'm just looking at my guide now, it's towards the end of each product page. And it's just before the restrictions where it says rain fast and all that. So it's in there, just look for the heading. So every product is a little bit different. Most of them, like if they'll have a statement on there, it's either 25 or 27 degrees. And you should not be spraying at that point. One thing that I should have mentioned, I guess, a product like Buctril M is something that's better sprayed in the evening, because then we've got it's getting cooler rather than getting hotter. And Buctril M is something that if it's sprayed in the morning when the temperatures are decent, but it gets really hot, it actually does a little bit more damage, especially crop damage, because it gets too hot later on when that kind of kicks in. I think it's 6 to 8 hours later is when temperature really affects that one. But normally you just need to be watching the temperature. When it is 30, 35 degrees, that is just too hot to spray, and you just need to wait. And I know that's hard to hear right now, but that's just, you shouldn't be spraying when it's that hot.
Okay, and I guess from that comment, it's probably better to maybe spray in the evening, because then you get the cool evening temperatures, than spraying in the morning where you got it heating up really fast.
Yeah, I guess, yeah, you have to look at where those temperatures are going to get to, yeah, and that type of thing. And again, but there's other factors too, but because again, with these extreme weathers, and you do have to watch for our temperature inversions, because our evening spraying, we are at danger of those inversions happening too. So if you are, spraying late at night, or not, sorry, in the evening, I mean, and then early in the morning, just really watch the weather for those inversions happening. But yeah, normally that's a bit better. If your temperatures are still decent, though, a morning spray though can be better, because your plants usually have they're not as droopy, and they've got a little bit more moisture in them from overnight, from the cool, they kind of recover overnight. We see that in the morning in our crops and stuff. And so sometimes too, if our temperatures aren't going to get too extreme during the day, then a morning spray might be a little bit better from that standpoint. But again, we have to stay away from those extreme temperatures And again, look at your labels for that. If there's a temperature restriction, it's on the label, and it will be, and it's in our guide. So it's easy enough to find.
Okay, good. I think there'll be a couple of questions later on in the panel. So going to right now switch over to our panel and go through some of the questions that have come up over the past week. And the first one, and we're seeing this in quite a few fields, whether it be barley or wheat, where it's germinated but hasn't emerged yet. And I think we kind of were concerned about this a little bit earlier on, and some of those still haven't come up. And so is it dead? And are we seeing any disease issues as to why these plants aren't coming up? So maybe Anne or David could reply to this one, but maybe you'll start with Anne.
Sure, thanks, Lionel. When it comes to this germinated but hasn't emerged, like the wheat or the kernels that are on the lower left-hand picture, they do have the coleoptile emerging. So I guess it really depends on the stage of germination. So if the kernels start germinating, but they haven't actually pushed that coleoptile out yet, they can take a break if soil conditions are quite dry, and then resume germination once they receive some moisture. Once the coleoptile is out, that's kind of like a more critical stage, and from some of the work that I've read, you would start being concerned if that's out and it hasn't pushed through the soil in, say, 6 days. Then you would kind of expect that it's not going to, or that, that it's not going to. And if it's out and it hasn't pushed through the ground in 6 days, I would expect that that's because there's just not enough moisture for germination. So perhaps it's reached the critical wilting point in this, or the permanent wilting point in the soil, and there's just not enough moisture for that crop to resume germination, and it would be dead. So yeah, I think that'd be there. I've heard from quite a few people that were anxiously awaiting their crops to emerge out of the ground, and yeah, I'd really just think about when it started germinating and how many days past you are before you would really start worrying.
Okay, any comments, David, if there might be some diseases starting to affect some of these crops that haven't come up yet?
Thanks, Lionel. I'm really skeptical that there are any diseases causing these emergence issues. I have wheat, oats, and barley in some small plots at the university farm, and they were all untreated. So if there were pathogens there, they are likely to be infected, but all those that I have dug up, there's no evidence of root diseases setting in. I do see a lot of stressed plants coming out and looking weak or yellow or crinkled, and that's all to do with the emergence conditions they're facing. The seeds were probably in moist soil, but they're pushing through a layer of dry or crusted soil that is probably really warm temperatures now, depending on the level of cover. You probably won't be able to assess whether or not disease has set in on the roots until you're at the 2-leaf stage and in wheat where the subcrown internode has lengthened sufficiently.
Hey Lionel, it's John here. I want to kick in, I'm not going to scold people about seed place fertilizer, I'm beyond that, but what I would mention is that a lot of this is seed place fertilizer, salt or ammonia injury, compounding it. And the research that was originally done on that stuff, looking at establishing our safe rates of seed place fertilizer, found that, they're able to sacrifice 15% plant stand of wheat or cereals without affecting yield. But that's because yield was made up for from tillering later, and that meant that maturity was advanced or delayed or made more uneven by 4 or more days. So if this ends up in thin stands, we're dependent on tillers to make yield, and be prepared for an ugly spray season and an ugly harvest.
Okay, thanks, John. I think that is going to kind of go into our next part of that question, where we're seeing wheat plants that are stunted. And will they be pushing through different growth stages quickly and reaching flag, or maybe even skipping our shorter growth stages? And maybe you guys can comment on that, because I'm definitely seeing fields where we've got wheat that's in the 3 to 4 leaf stage, and then we got wheat that's just coming through the ground. So are we going to be seeing anything like that? And maybe we could start with Anne again.
Sure, yeah, I've definitely noticed that in cereal crops where there's a huge difference in terms of plant size, probably just due to where the seed was placed. Like, where someone's turning and it's maybe a bit shallower, those runs all seem to be just coming out of the ground now, whereas the other ones would have been out of the ground 2 weeks ago. So yeah, there's definitely a lot of variability in the field. In terms of skipping growth stages, they wouldn't skip growth stages, but they would just run through the growth stages really quickly. So in these hot, dry conditions, the plants are stressed and the vegetative stage will be shortened. So they will still, go through all the stages like tillering, jointing, boot stage, etc. But they will likely be heading earlier and flowering earlier. In some cases, under extreme stress, we would lose 1 leaf. So instead of having, say, 8 leaves, it might have 7 leaves, but that's kind of the only difference that I have found in terms of different growth stages under this moisture and heat stress.
Hey, Anne, it's John here. I'm going to ask you a dirty question, but what's the chances I'm going to need a growth regulator if it stays this dry? Is that one of those stages that's going to be severely affected by this, even at this stage, and diminish the need for that type of intervention?
Yeah, in these conditions, we'll definitely see shorter plants. So yes, the plants are stunted now, and if this likely, they're going to be stunted throughout the growing season. So yeah, definitely, I don't think a lot of people will be spraying growth regulators this year. I don't, growth regulators are definitely most necessary or most useful under really good growing conditions. So when you're expecting a high yield, lots of growth, so kind of perfect growing conditions in terms of moisture and temperature. So this is probably not the year when a lot of people are going to be thinking about a growth regulator.
Is there almost like a timetable where we should expect plants to be at certain stages, like once they come through the ground, and in 3 weeks, should they be done tillering already and starting to joint, or is it going to depend on the growing season?
Yeah, it really depends on growing degree days. So I was looking into this a bit yesterday because we have such hot temperatures expected this week, just to kind of calculate how quickly plants will be going through the growth stages. So one thing to remember is that for cereal crops, their ideal growing temperature is, say, 22 degrees Celsius. That's not what we're going to be experiencing this week. And in the growing degree calculators, most of them discount any temperature above 30 degrees. So you wouldn't expect to have additional growth above 30 degrees because it's just too hot and stressful for the plant. So in these really hot temperatures, you could expect a new leaf, say, every 3 days. I can't recall offhand the number of growing degree days that to reach, say, tillering and then jointing and then boot stage, but that information is available. And Kim was mentioning some of the Manitoba egg weather information. And I think it was in the last crop report, but I could be wrong. But anyways, each week, the egg weather people do put together a table of growing degrees accumulated. So it's kind of interesting to look at that and see in your region, as of May 31st, how many growing degrees have we accumulated? I think it ranged from about 120 to 170. And then for all crops, you can kind of compare, what growth stage would you expect at this point with the accumulated growing degrees, and based on the temperatures, where do we expect to be? I can't recall offhand the exact growing degrees to say tillering or jointing, but it is all based on temperatures. And I just wanted to, one more thing, I've just been looking into the moisture and heat effects for cereals, and it's very tricky. Like, it's hard to know exactly how dry conditions and the hot conditions will be affecting things, but in some studies, they did find that the hot temperatures did cause more of a yield lag than low moisture conditions. So, these spring cereals really don't like the hot temperatures, and it's a bit concerning, having these hot temperatures now, when some plants may be entering the tillering stage, could mean that we'll have less tillers just because those plants are stressed.
And it's Kim here. I'm just going to jump in. Back to the weather station. Yeah, there's lots of really good information on our weather station stuff. And you can actually get the growing degree days for each weather station in the province if you want. So if anybody wants, and it'll actually tell you what % of normal you're at for any time period, basically May 1st until now, or the last week or whatever for a time frame. So if anybody wants to know how to do that, just give us a call or shoot me a text or something. But yeah, you can get that at every individual weather station and kind of see where we're at compared to normal, which I think is a good thing this year to take a look at that.
It's David here. I'm looking at the current Manitoba crop weather report. And for the central region, as Anne said, the growing degree days range from the 150 to just under 200 level. But as a percentage of normal, there are very few places where it's near 100%. It's all 60 some up to 80, 90. And as Anne said, these high temperatures are often discounted in the calculation of growing degree days. So useful growing conditions for the crop since May 1st are a little bit behind normal.
Okay, good. Thanks, guys. That was some real good information on that question. And I think we're going to be maybe seeing some of those issues in the field. While we're continuing on with this, we are getting questions about, what kind of stand should I be looking at out there? And we're getting that not just in canola and soybeans, but also in some of these wheat and barley stands. And maybe, Anne, while we're still on this topic, maybe you could maybe make a few comments about what would be a viable stand for these crops.
Sure. So yeah, I did have a question yesterday about a stand of about 11 plants per square foot. And in that case, I wouldn't recommend reseeding. So there is limited information on yields at low stands. So we did do some work at the diversification centers, and for wheat and barley and oats, we did find that there was no significant difference in most cases between stands of 16 to 39 plants per square foot. We didn't get as low as that, but just looking up some information from other studies, I did see a study this morning where they had wheat as low as 9 plants per square foot in a relatively dry year. And there was no significant difference in yield between that and say 21 to 32 plants per square foot. So, wheat does have the ability to tiller and overcome those low stands. That said, it's really tricky this year because if the wheat is stressed, we would be expecting less tillers. So it's hard to tell how that wheat will actually overcome those low stands and increase tillering. But, the conditions are dry. This wheat has a low stand because there's no moisture in the soil. So I don't think reseeding would really be the answer, especially because for wheat, we might be expecting 65% of our relative average yield at this time of year. So in those relatively low stands, I would just recommend keeping the wheat and hoping that we get some good rain for tillering.
Okay, good. Thanks, Anne. We'll skip over to the next question now. And I think Kim mentioned this a little bit at the beginning of her presentation or during her presentation, but I think it might be just important maybe to mention it one more time here about spraying after the frost and how long should we wait. And maybe if you could maybe just address that once more, Kim.
Okay, yeah, thanks, Lionel. Yeah, normally depends on the frost and how bad it was, but normally you need to be waiting at least 24 hours after a frost. If there's been successive frost, then of course it's now not 1 day, it's 2 days or even 3 days after a frost, and you need to be making sure that that the weeds are growing actively and going to take up that chemistry. You also need to make sure that the plants that are crop plants are growing actively and they're going to be able to metabolize it so it doesn't hurt them as much. So depending again on how severe the frost was, and the more severe frost, the longer you should be waiting. But if you've had successive frost a couple nights in a row, then you need to be waiting at least a couple days, 3 days minimum, I would say, and really be evaluating. the good thing is a lot of these weeds will grow quickly, and you can see whether they're pushing out new growth. You can see new leaves coming. Again, Lionel showed us those little canola plants that had lost one cotyledon completely. One was pretty sick looking, and yet it's pushing out a new leaf. But you need to have, you know, at least a good amount of leaf surface there. The majority of that plant needs to have good leaf surface in order for it to be taking up chemistry. So it's got to be actively growing. Both weed and crop need to be actively growing in order to start spraying again.
Okay, so on, let's say, for example, the canola picture I showed there, so would I wait for, say, 2 leaves to be there, or that one good leaf and start of another leaf before I went out to spray? I guess the question is, you know, herbicide tolerance, I guess, for the crop more than anything, I think is what we're.
Yeah. I would wait a little bit longer on that. That picture that's I'm seeing on screen right now, that's a pretty little canola crop, and you know, that's a pretty small leaf right there too. Having said that, like, our glyphosate systems are generally quite safe on the crop, but again, they're not immune. Our crops aren't immune. They're tolerant to glyphosate. So our glyphosate tolerant crops, anyways, they're tolerant. So you do want to make sure that they're actively growing. So I would be giving that a little bit more time if I could. Just to make sure that it's got a good, you know, we're going again. So, but having said that, again, the glyphosate system is pretty safe on the crop and stuff, but we still want to make sure we've got a good amount of leaf area, and that crop is on an upward trajectory for growth, not just you know, initially when they're initially recovering from frost. I mean, they're still under stress, so we need them to get growing again. So I'd be giving that I'd say at least another day, a nice full little leaf, another one coming, at least another day on that plant, maybe 2, depending on growing conditions.
Okay, great. Thanks, Kim. This one would be for John, I guess. A producer that actually called me, it was yesterday or the day before. Anyways, he hasn't finished seeding it. I think what he had left to seed was some cereals that he was going to grow for either silage or green feed. And looking at the forecast here and the extreme temperatures, he was wondering if he should be, I guess, changing his fertilizer plans and maybe, you know, putting as little fertilizer down or and waiting for the crop to come up. What would be your comments about that?
Okay, thanks for this. Yeah, the guidance at this point, looking basically at nitrogen and phosphorus, is that, yeah, I'd get the nitrogen out of the seed row and be prepared to, if he doesn't have an option, side banding or things like that, to put some on later when we know it's this dry. As far as phosphorus, hey, we're into June, it's getting warm. Soils are starting to put out natural phosphorus, where it's much more available now than it is on cool soils. So the response to phosphorus is not big when we do late seeding. So a little bit of pop-up phosphorus is probably all that's warranted here. You know, if it's sandy soils, it's under dry soil conditions that we get response to potassium. But since we're so dry, I'm a little reluctant to put much potash in the seed row right now, but that's something I'm expecting to see in the next couple of weeks if we get potassium deficiency showing up because of the dry conditions. So short answer for this farmer, yeah, stick some phosphorus and hold the nitrogen and be prepared to broadcast when you've got rain in the forecast.
So phosphate wise, would you recommend, you know, 10 pounds actual? What would you, I know if it's, should go by soil test, but like, is there a limit you would go to?
Oh, you're gonna stick me with this. Okay, well, yes, he should soil test, and if the soil tests are low, then he needs to maintain some of his phosphorus levels because there may not be soil reserves to carry. But if he's medium or whatever in soil phosphorus levels, then 10 or wherever he can move the lever on the seed drill to would be sufficient phosphorus for a little bit of pop-up. But again, the response to phosphorus in June is like minuscule compared to when it goes into cold soils.
Okay, good point. Next one for John Gavlosky. With the extreme heat over the next few days, how does this affect our flea beetle management? I've been getting some calls about some flea beetle problems already, and is these high temperatures going to make them eat more, or is it even going to be too hot for them?
Yeah, that's a really good question, and I guess a couple things to consider. One is that flea beetles feed most aggressively under hot, dry, calm conditions. So yesterday was a perfect feeding day. Today will probably be a perfect feeding day or a very good feeding day for them. Later in the week, it's hard to know. We don't have any research looking at optimum feeding temperatures for flea beetles. We know they like the mid and the high 20s. That seems to be optimum. But nobody's really studied, does the rate actually decrease once we get into the 30s? For other insects, people have studied that question, and with most insects, once we get into the 30s, the rate of feeding actually decreases, but no one's actually done that research for flea beetles. So anything I was to say there would be a little bit speculative, but again, once we're into the mid to high 20s, we know they like those conditions, and especially if it's calm and not too humid. That's when they feed most aggressively. Now, regarding control measures under the hot conditions, most of the products that people like to use belong to a group called the pyrethroids. And if you look on the label, almost all the pyrethroids have some sort of temperature restriction on them. Once you start getting into the high 20s and particularly the 30s, they do not work as well. So the ideal temperature to control flea beetles with those products would be high teens, low 20s. Once you start getting into the upper 20s, though, you're not likely to get as good effectiveness. So you may have to adjust your spraying. If the fields do need to be sprayed relatively quickly over the next few days, do consider doing it when it's not quite so hot out. So that might mean either an earlier in the day spray or a later in the day spray, which should still make you good contact with the flea beetles, but just don't be doing it during the heat of the day.
Okay, good. Thanks, John. And that takes us to the end of the questions for today. So just a few closing comments as normal. There's the Manitoba Ag Services offices that are available to get the crop protection guide. I think it's a very useful tool, so make sure you get that in your hands. Our ag adaptation specialists, there's the people in the province and their contact information, so please feel free to contact any one of those. I'd also like to take this moment to wish Ingrid a happy retirement. She is going to be leaving us, and we'll be definitely missing her, and hope she has a great retirement. And join us next week, June the 9th, when we'll be well into spring and hopefully looking at some rain in the forecast so we can get through some of these hot and dry conditions we're going to see over the next couple of days. So thanks for attending, and see you next week.